All right, we're going to move on to the angle bisector. Now, an angle bisector is a ray that divides an angle into two congruent, which is like saying equal, angles. So I can write a statement about my angle bisector here that says if ray BD, which is right here, ray BD, bisects angle ABC, then it divides it into two equal parts. Two equal parts. And we notate those equal parts with angles, those congruent pieces, with a angle swoosh that's the exact same. So if I have two angles or three angles, sets, pairs, then I'm going to do something similar to both. So I can do two marks, and that tells me that these two are congruent. And if I have another set of angles, I might use three marks, or I might use a mark with a tick mark on it to differentiate the congruent angles. Now, I could write a statement about this saying that angle ABD is congruent to angle DBC. Or I could even say the measure, so how much the angle actually is, measure of angle ABD is equal to the measure of angle DBC. Okay, we'll knock out some two examples about this and you'll be set to go. So this says ray MK bisects LMN. And again, I would draw a picture. It just visually can be helpful. And it doesn't have to be perfect. You're just trying to show that there is another ray in the middle. So I'm going to fill out, let's see, we've got the measure of angle LMK right here. It's kind of messy. There we go. Is 2x minus 12. And it does say bisect, so I can go ahead and assume that these two angles are congruent. And then it also says that KMN is x plus 23. Now, because this ray MK bisects the angle, that means those two sides are congruent or equal. So what can I say about angle, the measure of angle LMK and the measure of angle KMN? I can say that they are equal. So since they are equal, what can I do with these two expressions, the 2x minus 12 and the x plus 23? If the angles are equal to each other, what does that say about the expressions? Those are equal as well. So I'm going to take that 2x minus 12 and set it equal to x plus 23. And from here, I will follow my order of operations and get my x by itself, subtract out the x, add the 12, and I get x is equal to 35. Now I want to go back and double check what the question is asking me. Is it asking me to find just x, or does it ask me to do something else? So it asks me to find the measure of LMK. So that means I need to plug that x back in. So the measure of angle LMK was 2x minus 12. So I'm going to plug that 35 in. And get 58. So the measure of angle LMK is 58 degrees. All right, one more. And again, drawing a picture is so helpful. I have angle XYZ with ray YW bisecting. So I know these are congruent. So I'm going to treat these as two separate problems. A is a problem, and then once we move on to B, the information from A doesn't matter anymore. So please keep that in mind. So for A, it says if the measure of angle ZYW, this piece right here is 62 degrees, then what is the measure of angle XYZ, the whole thing? So if this is 62, what can we say about this piece up here, XYW? XYW, well, they're congruent, so this is also 62 degrees. So if these are both 62 degrees, what can we do to find out the whole angle? We add them together. So 62 plus 62 gives us 124. So something to think about, the measure of angle ZYW is equal to 1/2 of the measure of angle XYZ. So I just have to double it. So the measure of angle XYZ is 124. And lastly, we're going to get rid of these 62s because it's going to mess us up. There we go. Now, I completely ignore or disregard all information that was just given to me, and I treat question B as a separate question. I don't know anything about these angles unless it tells me. It says the measure of angle XYZ, the whole thing, is 148. But I have two equal pieces on the inside. So to find the measure of angle XYW, I'm going to take 1/2 of the measure of angle XYZ, and that will give me the measure of angle XYW. So 148 divided by 2 gives me 74. So the measure of angle XYW is 74 degrees.